In question 11, you're given the function f of x equals 2x plus 8, and you're asked to determine the rule of the inverse of this function. So basically find f inverse. So let's do that. We have y equals 2x plus 8. I'm just recopying the rule. And now I'm going to interchange the x with the y because I'm looking for the inverse. So interchanging x and y, I get x equals 2y plus 8. And now solving for y, I bring 8 to the other side. So x minus 8 equals 2y. And then divide both sides by 2. I get x minus 8 over 2 equals y. So my inverse, y inverse, f of x inverse, is x minus 8 over 2. So let's see what happens now now that we know what the inverse is, in the second part of this question, what they're asking you to do is determine the composition of f inverse with f. So basically, put f inverse and f together and see what it gives you. So inside the x from my inverse, I will put the function f, which happens to be 2x plus 8. So let's open the parentheses for where I'm going to put in my function, because I have x minus 8, so really what I have is 2x plus 8, close the parentheses, minus 8, all of which is divided by 2. So what this gives me is 2x plus 8 minus 8 over 2, 2x plus 8 minus 8, all divided by 2. That gives me 2x over 2, and then reducing further, I get x. So we see that the composition of f prime of f inverse with f gives me the function x. We get y equals x. Now let's see what happens if I reverse the composition, so that now instead of having f inverse, I have f composed of f inverse. Let's see if that makes a difference. So my function f, let's try to remember what it was. It was 2x plus 8. So I have 2 times, and inside my x I'm going to put my f inverse, which is x minus 8 over 2, plus 8 to finish my function. Now I'm going to distribute the 2 that's in front of my brackets inside, but I notice that it cancels with the 2 over here, so what I'm left with is x minus 8 plus 8, and then the 2 8's cancel, and what I'm left with is x. So clearly, it doesn't make a difference whether I put the function first and then the inverse, or the inverse and then the function. Either way, I end up getting the function f composed with f inverse equals x. So really, whenever you compose a function with its inverse, you will always get the rule y equals x. You always get x when you compose something with its inverse. Now let's try to prove that generally. So let's see. Let's say you've got some general function f that has the form ax plus b. Then let's find the inverse of that, f inverse. How do we find that? Well, what we do is we interchange the value of x and y. So let's not write f, let's write x equals a times f, because in this case my function is called f instead of y, plus b, and now I'm going to solve for f. This is how I find the inverses. So I bring the b to the other side, I get x minus b divided by a equals f. So this is my inverse. So this is basically my general straight line function, and this is generally how the inverse will look like. And let's try to compose one into the other. Let's put f composed with f1, and what that looks like is a times I'm going to open brackets, and then I'm going to replace inside the value of x, x minus b divided by a. Oops. Close my bracket, and then add b to finish my function over here. So what that does is the a and the a cancel. You're left with x minus b plus b. The b's cancel, and what you're left with is x. And what you see is, it doesn't matter what function you have, you will always end up with x when you compose something with its inverse. I'll leave it to you as an exercise to see what happens if you do f inverse composed of f, so the opposite of what I just did here. So try it yourself, but you should see that you get x as a final solution when you do it this way also.